All right, so a very good morning to you all, and welcome to today's class. Today we'll be looking at the introduction to data processing system. Introduction to data processing system. So far, we have covered definitional characteristics of computer. We have covered computer hardware. We have covered computer software. So today we'll be looking at introduction to data processing system. Now, a data processing system is a combination of machines. It's a combination of machines and people that for a set of input procedures finds a set of defined outputs. All right. So in this case, we're interested in, is a system. And once you're talking about a system, you're talking about interconnection of different entities or different units in order to achieve a single goal. For instance, if you have somebody here, he has eyes, he has nose, he has mouth. This human being is a full system, which means that if he sees something, there is likelihood his leg is going to run. If he sees something, it's going to run, which means that this is an input unit that receives something, and then this is where the action takes place. Or probably with his ears, if he hears something and it is not pleasant, you will see it in his facial expression. Okay, so we are saying that data processing system is a combination of machines and people that for a set of input procedures, a defined set of output. So your output is dependent on your input and also the processing that is done. That is what is going to determine your output. Now, the input and output are interpreted as data, facts, and information. The output is where the information comes in. Information is a processed data, and information is conveying a meaningful idea. That's information. Okay, so basically that's it when it comes to the issue of information. Now, additionally, we said inputs are interpreted, which means once this data or this fact is received, there is an interpretation that is done. Now, we will get there. We have different types of data. We have what we call the numeric data, and we have what we call the character data. Now, the numeric data deals with numbers or numerals. The character data deals with all characters. It can be numbers, it can be symbols, it can be alphabets, it can be any other thing, right? Now, the numeric data, like we said, represents form of numbers known as numeric data, while the character data is divided into two. We have what we call the string data, and then we have what we call the graphical data. Okay, now the string data, what is the difference between the string data and the graphical data? The string data consists of the sequence of characters and made up of alphanumeric and graphical, very important. So we say it's made up of what? Sequence of characters. That's what makes a string, is a string. And this sequence of characters can be alphanumeric, which means it can be alphabet, it can be numbers, it can be graphics. Alphanumeric data consists of alphabets, numbers, and special characters, while graphic data possible that pictures, charts, and maps can be treated as data. Now, when you're talking about pictures, charts and maps, when it relates to graphics, is basically talking about these pixels. You see, if I'm putting pixels, it's just these dots. all these dots you put together that forms an image, it's pixels. So the denser the pixels, the more sharper that image is. The denser the pixel, the sharper the image is. And so sometimes you see in your camera, they say this megapixel, that megapixel. So the higher the megapixels, the sharper your image. Now, information is a collection of data which what conveys a meaningful idea. Very, very important. You put data that have been processed and conveys a meaningful idea. It's like saying I take in sound and it brings out music. The music conveys a meaningful idea. In fact, there are sounds or music that gives messages. Okay, it gives messages. So that's information. All right. Pictures. There are pictures that gives meaningful ideas. Yeah, data that gives meaningful ideas. So it may provide answers to questions like who, which, when, why, what, and how. That's this information. It provides all this, answers to these questions, right? Now, this meaningful organization is information or observation and recordings are done to obtain data, while analysis is done to obtain information. When you're talking about analysis, you're talking about examination of this data. So let's look at data processing. Data processing says that any operation or set of operations performed upon data, whether or not by automatic means, such as collection, recording, organization, storage, adaptation, or even alteration. And he says what? To convert it into meaningful information. To convert it into meaningful information. That is data processing. Yeah? Either set of operation or maybe an operation. What are examples of this operation? This is this we're talking about. Collection is an operation. Recording is an operation. Organization, storage, alteration, adaptation, and so on. All these ones are different types. There's so many operations. So far, you perform this operation on data to get or to convert into meaningful information. That is data processing. Now, data processing has a circle. Let's look at the circle. It says once the collected data, excuse me, once data is collected, it is processed to convert it into useful information. The data is processed again and again until the accurate result is achieved. So the data processing is very important activity and involves very careful planning. Okay. Now, this is the circle. Usually, data processing activity involves input, processing, and output. Input, processing, and output. So we're going to look at each of these. We'll look at the input, we'll look at the processing, we'll look at the output. Now, what are the input steps? When you're talking about input, input is the process through which collected data is transferred into a form that the computer can understand. Very, very important. This is like your native language. Remember, we said the computer has its language, and the main language of the computer is the machine language. The machine language. Now, the machine language is binary, where you have zeros and ones and things like that. That's the machine language. So the input process is where you collect the data or you receive the data, and then you now convert that data into a form that the machine will understand. That is the input process. It is very important step because correct output result totally depends on the input data. Why is this important? Now, we are saying that if I enter, no, let's say A, B, capital letters, is going to be converted into, a binary. If I entered small a, small b, is going to be converted into binary. If I entered plus or comma or at, any character is going to converted into binary. You understand? If I entered maybe a picture, let's say I entered maybe a particular picture, that picture will be converted into binary. You understand? If I enter musical sound, maybe music or sound is going to converted into binary. Why? Everything is converted to machine understandable form. That's the input. So it's a very, very important step. Now, it says in the input step, following activities can be performed. Now, let's look at it. Step 2, verification. So you see, input, we have verification. The collected data is to be determined whether it is correct as required or not. Remember, we have different input devices. Keyboard gives us alphanumeric and special characters. So it needs to be verified that that is so. You don't expect keyboard to give you images. What do they call it? Mouse and joystick, they give you, or touchpad, they give you command, control, and signal command. All right? It needs to be verified. Scanner, cameras, they give you images. It confirms or verifies that that is so. Microphone, you take in voice, you confirm that that is so. You understand? So that is the verification. Now, if errors occurred in collected data, data is corrected or it is collected again. And all that is done at the input stage. Then the next one is coding. The verified data is coded or converted into machine-readable form so that it can be processed. Remember, we said that it needs to be converted to binary. So the coding stage is where this binary is converted. If whatever it is that you take, whether it's alphanumeric, whether it's pictures, is now converted to machine step. So that's the coding. And then the final stage of the input process is storing. It says that the data is stored on the secondary storage file into a file. Now, what are we looking at? Under inputs, what do? You collect data. Is that not so? You collect data. There's what we call verification. Then after the verification, you do what? Coding and conversion. Convert it to machine understandable form. After that one, you do what? You do the storing. All these things are stages in the input process. Then we go to stage 2, which is the processing. Remember, we said we have input, processing, and output. So we have finished the input. The imputed data is verified, then it's coded to machine understandable form, and then it is stored. Now, for data processing, it says the term processing denotes the actual data manipulation technique, such as classifying, sorting, calculating. That's what happens, such as, classification, storing or calculating, summarizing, comparing, etc. Then that converts data into information. This is processing. Now, processing also has its own stages. the data is classified into different groups, such as groups, subgroups, that each group or subgroup of data can be handled differently. So classification is one processing. So maybe it takes in the data and then it says, okay, male, put males together, put females together. Under the male, it says put the single separate, put the married separate. Under the female, put the single separate, put the married separate. Under the single, it now classifies them again. Those younger between ages of 1 to 50, 1 to, let's say, 10, then 11 to 20, you classify them separately. Then, you do classification, or maybe based on race, based on sex, based on height, you do different classification. And the reason you do the classification is to enable the processor to get access to this data fast, especially when in need. Okay. Just a minute. Sorry, let me. All right. Sorry for the glitch. So that is classification. Classification is under processing. Okay. The next one is storing. So after it has been classified, then it then goes ahead to store this information. So the data is arranged in an order so that it can be accessed quickly as at when required. Then number 3 is calculations. The arithmetic operations are performed on numeric data to get the required results. The processor, the CPU has different units. The CPU has what we call the ALU. The ALU is arithmetic and logic units. Now, what this unit does is that it manages all kinds of arithmetic operations, calculations and stuff like that. It manages all of them. Then the next one is control units. The control unit is responsible for generating signals, the signals and commands that the processor is going to use. Then it has the registrar. The registrar is responsible for documenting all processing activities that have taken place. So all these things are found in the CPU. Now, you see, in the processing aspect, we have looked at what it's going to do. Well, it will do what? First, classification. Is that not so? It does classification. After classification, then it stores it. After storing, then it does this calculation. And mostly this calculation are related to the ALU, the arithmetic and the logic units. Then after the calculation, then it does summarizing. The data is processed to represent it in a summarized form. Okay, so that's the 4 stages of processing. All right, remember we said what? Classification, storing, calculations, and then what? Summarizing. So those are the 4 stages. Now, the third data processing cycle is the output. It says after completing the processing step, output is then generated. Okay, the main purpose of data processing is to get required result. So mostly the output is stored on the storage media for later. Okay, so sometimes you project it, but the output also has its own stages. The stage number 1 in the output is retrieval. Remember that after the processing is done, it will store it. Then And all that it has been doing, remember, is doing using machine understandable form. It's using machine language. So what it will do, number one, is retrieve this information. The output stored on the storage media can be retrieved at any time. All right. Then after retrieval, then it will do what we call conversion. The generated output can be converted into different forms. Because it is in machine understandable form. Now it needs to be converted to human understandable form. If it is graphics, it will bring it in graphics. If it is text, it will bring it in text. If it is sound, it will bring it in music. If it is whatever it is, so it does conversion. So first is retrieval. Second is conversion. Then 3 is communication. The generated output is sent to different places. For example, weather forecast is prepared and sent, or maybe you print out your information, or you send it via email, or you project it using the projector, or it displays on the video or monitor or whatever visual unit you have. So communication, all right? So we said number 1 is what? Retrieval. And where does it retrieve it? From the processing storage. Is that not so? Then number 2, it does conversion. Remember, in the input stage, once it receives it, it will do what? Coding and conversion. Once it verifies it, it will do coding and what? Conversion. It will convert it to machine understandable form. The processing stage will all do processing using machine understandable form. Now in the output stage, it has to convert it back. Then you have communication. Now, types of data processing system. We have what we call the scientific data processing. Now, scientific data processing usually involves a great deal of computation upon a relatively small amount of input data. That's what happens. You do so much computation. It's like when you go to the hospital, you say, I'm sick. The doctor sends you to the lab. The lab technician will not collect a bucket of blood to do this test. No, they will just take a pin and touch to your finger and just or on your arm and then fetch out some small amount of blood. And this small blood that they will take, they will be doing so much computation, a great deal of computation. One test to the other, one test to the other. You understand? That's what happens. So, great deal of computation on a small amount of input data. All right, that's scientific processing. Now, the commercial data processing on the other side is that it is like the inverse. It involves a large volume of input data with relatively small operation. Large volume of data with few computational operation. Maybe you are trying to process payment staff payroll. You have maybe 3,000 staff and you want to initiate payment. You just do small computation and then everybody gets. You understand? So the difference between scientific and commercial data processing is one involves a great amount of computation on small data. The other does great data, small computation. Then finally, data analysis. Data analysis is a body of methods that helps to describe facts. Describe facts, detect patterns, develop explanations, and test hypotheses. That's data analysis. All right. So when you're talking about analysis, it has to do with examination, or it means to study. Is that not so? So when you're looking at data analysis, you're looking at, methods, body of methods that helps you to describe facts, detect patterns after series of studies and examination and things like that. All right. the computer process operation. A computer can perform only the following 4 operations, which enable computers to carry out various data processing activities. We have input, output operations. A computer can accept data from and supply processed data to a wide range of input-output devices. These devices, such as keyboards, display screens, printers, make human communication possible. Then computer can do calculation and text manipulation. That is word processing. So computer circuits perform calculations on numbers. They are also capable of manipulating numerics and other symbols used in text with equal efficiency. And then logic comparisons and operations. Computer also possesses the ability to perform logical operations. A computer can perform such operations, and depending on the results, follow a predetermined path to complete its work. So this ability to compare it is an important property of computers. That's the end of today's class. We'll now unmute you guys to take your questions.